Hello, Prof. Mo here of chemjoint.com. Let's describe alkanes. Alkanes are hydrocarbons that contain only single sigma bonds. Okay, so they contain only single bonds, no double bonds, no triple bonds. The general formula for alkanes happens to be CnH2n plus 2. The n right there is the number of carbons. So say you have 2 carbons, then the whole formula will be C2H2 by 2 plus 2, which happens to be C2H6. And with the 2 carbons, we'll call that an eth. We'll call that an eth. And if it's the alkane, we'll add on the eth we'll add ane. So alkanes, the alkane name is divided into 2. You have the alk part and the ane part. The alk part goes with the number of carbons that you have. Alright, so generally if it's 1 carbon, it's meth. You add ane, it will be methane, and it's gonna look like this. In that case, it will be a CH4, right? Because we said you're gonna go C1H21 plus 2, which is CH4. And then ethane with 2 carbons, like I said, is 2H6, written like this as a condensed formula. Ethane, and it's drawn like this in one line. We did this in another video on how to represent organic structures. The moment you put down your pen, that's 1 carbon, the other end is another carbon. A carbon has to have 4 bonds, so we have 3 implied hydrogens on that carbon, 3 implied hydrogens on that carbon. This is called the line angle formula. This is called the IUPAC name, and this is the condensed representation of the said hydrocarbon. So 3 carbons will be prop, 4 will be but, 5 will be pent, and it's an alkane, ane. If it was an alkene, it will be ene. Alkyne will be yne, suffix part of the name. 6 carbon is hexane, as in hexagon. 7 will be heptane, 8 octane, 9 nonane, 10 decane, 11 undecane, and then you have 12 dodecane, 13 I believe will be dry decane. You don't usually just have straight chains. Sometimes you will end up with structures that are branched. So like that's a straight chain structure right there. But you can also have it branched to where you have something popping out of the longest chain, or something popping out of the longest chain, or something popping out of the longest chain. Okay, so blah blah blah. Like a tree grows, you will have the stem, and then you have the branches. Those branches are called substituents. Especially they are called alkyl groups. So you will take the 1 carbon, 2 carbon, 3, 4 carbon representation to define it. So if it's 1 carbon, instead of calling it methane, you call it methyl. So you drop the ane in alkanes and replace it with an yl. This will represent the alk part, and then you join it to the yl. You'll get what we call an alkyl group. Those are usually substituents having carbons, but sometimes you have substituents having halogens. You'll see them in the next slide. Okay, so as usual, we imply the hydrogens. The hydrogens are there, they're just not shown. Okay, so you see these hydrogens right here, they're implied. If this is the parent chain, maybe this is the longest chain, and this is the branch, just like it's branching off here. Then you start counting from the carbon attached directly to the longest chain. Like in this case, I should have counted this as carbon 1 and carbon 2. I have 2 carbons in my substituent. It has to be an eth. It's a hydrocarbon substituent, so I add YL. Alright, and then you have propyl. In fact, usually this is usually called N-propyl because the substituent on the longest chain can also branch itself. So like here you see we still have 1, 2, 3 carbons on the substituent, but it's branched. This type of substituent that takes a Y shape is called isopropyl. Okay, it's called isopropyl commonly, but the preferred IUPAC name will be 1-methyl-ethyl. You can see that on the first carbon we have a branch 2, we call that a methyl, but you see you have 2 carbons on the longest chain of the branch, so we call these, starting by calling the substituent name on carbon 1, that will be 1-methyl. We call the whole thing 1-methyl-ethyl because the longest chain happens to have 2 carbons in the substituent within the substituent. So isopropyl can also be called 1-methyl-ethyl. And then we go to the 4-carbon one. It has 4 carbons in it, and it's straight chain, so people will call that normal butyl because it can also branch in 3 ways. Okay, so sometimes we'll have this long normal chain substituent branched. So like in this case you have 4 carbons, but also in this one you have 4 carbons. This type of substituent is called a sec butyl because there is a substituent on the first secondary carbon of the substituent. This is called secondary carbon because it's bonded to 2 other carbons, hence it's secondary. Okay, so sec. Remember the sec is in italics. Usually when it's italicized, you don't consider the S in the alphabet rule. We'll talk about that. So let's look at this branched butyl. So the longest chain in the branched butyl has 3 carbons, so it has to be a propyl. And then the first carbon of the longest chain of the substituent has a CH3. We call that a methyl or a methyl, whichever way you want to call it with your accent. It's on the first carbon of the substituent, so we will call the entire substituent, starting with the substituent of the substituent, 1-methyl. You define where the substituent on the substituent is. The methyl group is on the first carbon, but the longest chain is a propyl. So this will be the preferred name of the sec butyl, isomer of normal butyl substituent, structural isomer of the normal butyl and butyl substituent. So this is how you draw it without showing the hydrogen. It looks like that, sec butyl. Apart from that, we have tert butyl. I usually joke and call the tert butyl a chicken foot because it does look like a chicken foot. You know, it looks like a chicken foot because of the structure. Anyway, the carbon right there is bonded to 4 other carbons, so it takes the shape of tetrahedral shape to the 4 carbons. We call it tert butyl. And then you can see that the longest chain of the tert butyl is 2 carbons. So we have 2 carbons in there. So it has to be an ethyl in all. But the first carbon of the tert butyl with 4 carbons in it has a methyl group on carbon 1 and a methyl group on carbon 1. So there are 2 methyl groups on the same carbon. So we'll say 1, 1. You have to define both positions for each, even though they are sharing a carbon. So 1, 1, and because they are 2 of the same type, the preferred IUPAC name will have to say di, and then there are 2 methyl groups. So we say dimethyl ethyl. Ethyl is the longest chain, continuous chain in the substituent. So the tert butyl is otherwise called 1,1-dimethyl ethyl substituent, and implying hydrogens, that's how it's drawn. By the way, the dash there is used, dash there is used, dash here is used to separate numbers from alphabets. We will use this in naming, so keep that in mind. Alright, so again, just to wrap up this slide, whenever a hydrogen on the longest chain is substituted with a carbon group, we call that substituent an alkyl group or a substituent. Okay, so it could be a methyl there, or even this, adding a carbon on there, it's a methyl. Okay, which is just the same representation of what we have up there, implying hydrogens. You will see that you have substituent and you have these other types of substituents. Let's go into IUPAC naming of alkanes. Alkyl groups are not the only substituents. You can also have other types of substituents. Like here I'm showing you that we have halogen. We have halogens as substituents. You see that's a halogen, a halogen, a halogen. And then here you have an amine. If you don't know what a halogen is, those are just main group 7 elements: fluorine, chlorine, bromine, iodine. You could also have an iodine, in which case if I had an iodine, then that iodine substituent will go with the name iodo. The name of these, usually we give the substituent the least position possible. So we go with a 2 rather than going with a 3 in numbering from the left. So the name here will be 2-iodobutane. We are coming to specifics. Anyway, the point here is that you don't just only have alkyl groups as substituents. You can also have halogens, even amines, and so many others like SH thiols. IUPAC naming. So what are the rules of naming alkanes? The very first thing you want to do is to find your longest continuous chain. So let's say this is the chain that I have. Okay, I will number it from the left or from the right. So let's assume that's the left numbering and this is the numbering from the right. I always end up on the A, and that we said it's an oct, and because there's no double bond, it's gonna be under alkanes, octane. Here, whichever numbering direction is correct, because there's no substituent. Usually you want to give this number the chain in a way to give the substituent the lowest number possible. We call that the locant position. You want to give it the least locant position on the chain. Okay, and you also keep in mind that the longest chain is not always just going left right. Sometimes it can branch from left to right. Let me show you example on step 2. So let's say that you have this. Keeping it an octane, so 1, 2, 3, 4, 5, 6, 7, 8. Numbering from the left to right, or from the right, 3, 4, 5, 6, 7, 8. Where the corners are, those are carbons. We discussed that in another video on how to draw organic structures. Okay, the moment you put down your pen, it's a carbon. At the end, there's a carbon, and where there are corners in the zigzag drawing, line angle drawing, there's a carbon. There's also a carbon here, but it wasn't numbered. So this is what we just discussed. This will be taken to be an alkyl group, and specifically, it is a methyl. And the methyl is on either the 3rd or the 6th carbon. We'll decide soon what's the correct numbering. So it says we give the substituent the least number position. We call it a locant position. So I don't want to give it a 6. So the white numbering is wrong. I will go with the yellowish numbering. And so the 3 is preferred over the white numbering. The yellow numbering, the 3 is preferred over the 6. So the name will include first citing the alkyl group, and it's on the 3rd carbon. So you say 3, use a dash to separate numbers from alphabet, 3-methyl, and it is an oct. There's no double bond, octane. So what if what we were provided is this. What's the longest chain in that? Let's start numbering from the left and see. 1, 2, 3, 4, 5, 6. No. 4, 5, 6, 7, 8. Okay. However, I could go 1, 2, 3, 4, 5, 6, 7, 8, and 9. The 9 wins, so I get rid of the other numbering. I go with the 8, because we always want to go with the longest chain. So here I'm emphasizing that the longest chain is not always going from normal left to right. Sometimes you want to be sure to track the molecule around. Okay, so like here I had to curve down. Okay, then you would write the name of the compound, starting with the substituents, using a hyphen to separate the numbers, then the name of the substituent followed by the parent's name. No spaces between alphabets. We've already done this step, but I'm gonna give you more examples. So let's say what I had is this. Then the name will be including the substituent here, which has an ethyl with the lowest number. The name for this will be 3-ethyl 6-carbon chain hex N. I ignore the white numbering because it gives my ethyl 4 instead of 3. Okay, use dashes to separate numbers from alphabets. Usually no spaces between alphabets. Sometimes you have 2 or more substituents present. When they are non-identical and they are at equivalent positions from whichever direction of numbering, you want to use the next protocol, which is alphabet rule. Give the lower number to the name containing an earlier letter in the alphabet. Example, let's assume that you have this structure. Okay, let's assume you have that structure and that you have a branch here, and you also have a branch there. Okay, this molecule has the longest chain with 6 carbons, so maybe 1, 2, 3, 4, 5, and 6. Okay, and if you try numbering it from the other side, it will be 1, 2, 3, 4, 5, and 6. Usually, if you want to find the correct numbering when you have multiple substituents, you want to use the sum of locands shortcut to determine that. I'll show you. So you see that in this color, a substituent is on 3 and 4. This is a substituent here, this is a substituent. So I can say 3 plus 4 equals to 7. The one that gives me the least answer will be the correct one, because you want to give substituents the least locant position possible. Also, for this bluish color, I have something at 4 where the 3 was and at 3 where the 4 was. See how both of them are 7? I cannot choose any of these. So when that happens, you want to use the alphabet rule, paying attention to the first letter of the substituent. With the exception of sec and tat, you don't consider the S and the T in those because they are in italics. I mentioned that before. So E comes before M, so E should be given priority. The correct numbering should be the one that gives the ethyl group the least number. So this color numbering is wrong because it gives the ethyl 4 instead of 3. Remember again, E comes before M in the alphabet. And I'm using the alphabet rule because the numbers did not help me. I would have gone with the one that gives me the least locant location of substituents. Okay, so the correct numbering we're going with the bluish naming will be one that gives ethyl 3 and methyl 4, and the name will always be written following alphabet rule, not because 3 is lower than 4, but because E comes before M, so it will be 3 ethyl. We list the ethyl first, dash, then 4 methyl. The methyl group is on the 4th carbon of the correct numbering of the longest chain, and then you have 6 carbons, so hex N. That will be the IUPAC name for that. Okay, now that's not the only situation. So suppose you have the halogens. Maybe we have a bromine here and we have a chlorine here. Again, if you try numbering, let's say 1, 2, 3, 4, 5, and 6, and I number from the right 1, 2, 3, 4, 5, and 6, you will realize that if you go with the white using the sum of locant positions, you have something at 2, you have something at 5. So 2 plus 5 will give you 7. If you go with the greenish, you have something at 5 and something at 2. So it will be 5 plus 2 equals to 7. We would have gone with the sum of the locant position that gives us the least total. But looking carefully, we see that they are all the same. So we have to go back to the alphabet rule, which is the second rule you'd follow, where the locant positions are not helping. So you'll carefully look and see that, and notice that the bromine, when it's a substituent, it's a bromo. We say that. The chlorine, when it's a substituent, it's a chloro. Fluorine will be fluoro. Iodine will be iodo. You'll notice that B comes before C. You want to prioritize the B. So we go with the green numbering because that gives the B a 2 rather than a 5. The white numbering is wrong. So the name to this compound will go 2-bromo. So we'll have to name it 2-bromo, and then the chlorine happens to be on the 5 in the green numbering, so I did not cancel that. That was a mistake. So 5-chloro, and then it has 6 carbons in the longest chain, so hex, no double bond, N. This type of structure is called an alkyl halide, and you will discuss it when talking about substitution reactions 5 chapters or 6 chapters after this. So 2-bromo 5-chlorohexane would be the name for this, where the number locant position did not help. We had to use the alphabet rule based on the first alphabet of the substituent. When 2 or more substituents are present and they are on the same carbon and they happen to be probably you're having them similar, you want to record that position where they are sharing the carbon. You want to record that number twice, especially when they are identical and they are on the same carbon. In this example, you'll see that that's a 3-ethyl and this is also a 3-ethyl because they are sitting on the same 3rd carbon. They will show up in the final name as 3,3 diethyl. The methyl groups here, they will show up as 6,6 dimethyl. Di has to be there, but in this case the D will not be considered in alphabet rule. It's not in parentheses. If it were in parentheses, we will consider it. You'll see it in another example. So the full name of these having 9 carbons will be 3,3-diethyl. Remember, I'm considering E and M, not the D's. These will be considered if they were in parentheses. We'll see that rule soon. 3,3-diethyl hyphen 6,6-dimethyl, and then you call it non-N. So be very careful in this rule to list the number twice if they are the same on the same carbon. And then if you have multiple similar substituents, always use di. D here is not considered in alphabet rule unless it was in parentheses. Let's look at another example. When you have two or more substituents in the chain and you have a problem where you have a competition of the longest chain in the structure, you want to choose the longest chain that has the greatest number of substituents. That's the rule. In this example, you are seeing that I could go this way, starting from here to here. It's an 8. But I could start also from here and meander around trail. I still end up with an 8 up there. Those are the two different ways we can number this. Of course, I'm not saying that this is a correct numbering. We'll have to do the second set. I'm not saying this is a correct numbering. You do the second set. But first, let's find the one with the greatest substituents. Any carbon that is not numbered is going to be a substituent. If you number it this way, or even alternatively, if you want to number it this way, you will always end up with only 2 substituents, isopropyl there and ethyl there. So this gives me 2 substituents. But in this one, if I go this way, or I even number it like this, I'll always end up with that not numbered, not numbered, not numbered, not numbered. I have 3 substituents. This is the correct consideration of numbering. So we get rid of this. We want to go with the one with the greatest number of substituents. With the yellow numbering, I have something on 2. So it's 2 plus, something on 3, and then something on 5. I sum these up, I get 10. With the white numbering, I have something on 7 where 2 was. I have something on 6, and I have something on 4. So that gives me a total of 17 with the white, and a total of 10 with the yellowish. So I want to go with the yellowish numbering, and the correct name of this has a 2-methyl, it has a 5-ethyl, and then it has a 3-ethyl. Now you see how we have 2 ethyls groups on the longest chain. So the name of this will go first with the alphabet rule, the ethyls. Notice that I'm listing 3 and 5 because I want to account for the ethyls, all ethyls first. But if you write it like this, if you say 3,5-ethyl, you are wrong. You have to say 3,5-diethyl. Okay, we write it again. It will be 3,5-diethyl, not just ethyl. And then the methyl group on 2. So 2-methyl. I'm writing methyl group next because M comes after E. Again, we don't consider the D. In this case, the di is not in parentheses to be considered. So 3,5-diethyl, 2-methyl, and then octane. That would be the name of that compound, with the ethyls on 3 and 5 and the methyl on 2. Longest chain, 8 carbons. So remember to go with the longest chain that maximizes substituents. That's what this is showing. Next rule. Okay, sometimes you might have complex substituents. So in this case, we have these complex substituents like tert-butyl, isopropyl. You could even have isobutyl, or you could have, sec-butyl. Your instructor might go easy on you and just let you use the isopropyl tert-butyl stuff. But your instructor might also, some instructors might also want you to avoid using that completely, and they'll want you to use the methyl ethyl preferred IUPAC naming of those substituents, which I showed you when we started. So in this case, I can try to name this compound, but first of all, first things first, find the longest chain, number it from either side. I see that I'll always end up with a 6 and a 4, that makes 10, and in white 6 and 4, that makes 10. We wanted to go with the one that gives the substituents the least location possible, but these two are not. So we go to the second rule, which is the alphabet rule. In alphabet rule, I'll consider the I because ISO is not italicized, but I will not consider the T. T is in italics, so I'll consider the B. So B wins over I. I need to give the TAT bureau group the list number position, and it's gonna be going with the white numbering. So the yellowish numbering, whatever that color is ignored. So the name of this compound will be 4 TAT. We put a hyphen because this is in italics. TAT bureau, and then 6 isopropyl, and then 9 carbons. It's a non, it's an alkane, non-N. If the instructor wants you to avoid all that and wants you to use the preferred IUPAC name, avoiding isopropyl, isobutyl, TAT bureau, sec bureau stuff, you will want to use the actual IUPAC naming of these substituents. Now you see that for this substituent here, the longest chain in it has 2 carbons. So this is not numbered. That's a methyl. It's sitting on 1 carbon, carbon number 1. So we call that 1 methyl, then the parent chain in the substituent, ethyl, not ethane, because the substituent in itself, you say ethyl. So isopropyl could otherwise be called 1 methyl ethyl. And here again, the longest chain has 2 carbons in the substituent, so the name will end up with something like ethyl of the substituent, but you do have 2 methyl groups on the first carbon, so it should be 1 dimethyl, all in parentheses for the TAT bureau. Okay, so what would be the official name of this? This time, because the D is in parentheses, we have to consider the very first alphabet. So you always consider any first alphabet in the parentheses. D wins over M. This D would have been ignored if it was not in parentheses. I would have been considering the M like we did in the last slide. Okay, so now we will give the name of this, prioritizing position of the TAT bureau because it has a D. It will end up on a 4, right? If I'm to number it from the right, 6, 7, 8, 9. This time I don't consider this top numbering. I prioritize the lower numbering, which happens to be in yellow. So the name will be 4, and then parentheses, that's the position of where this B group is that has this whole name. 1 dimethyl, and then longest chain in it is an ethyl. That whole part represents the TAT bureau. Hyphen, now we are ready to represent the isopropyl, which is 1 methyl ethyl. Where is it? It's on carbon number 6. 6 parentheses, 1 methyl ethyl, and then of course this is a non, 9 carbons in the longest chain, there's no double bond, Nen. This represents a name that avoids using isopropyl TAT bureau stuff. Whenever you have complex substituents, this most likely is a preferred way of naming it. Okay, remember again, this one would have represented the TAT bureau, and this one represents the isopropyl, just written in the preferred IUPAC way. I hope that helped. In this case, with this complex substituent present, following up with what we just learned, okay, this would have been the TAT bureau, but let's see how it will be called in the preferred way. So in the preferred way, I'll number the longest chain in my substituent. Anything that's not numbered is a substituent of the substituent, and it happens to be methyls. So the name of this will be 1,1-dimethyl. Why? because those two methyl groups are on the first carbon of the longest chain of the substituent, and then the longest chain in the substituent is an ethyl, everything in parentheses. So that's how we get this. This one is normal, it's just an ethyl. So I will have to consider E and the D in parentheses. If the D was not in parentheses, you will not consider it. So the name of this will have to prioritize the tert-butyl, but I see that the number here is 6 and for the tert-butyl and 4 for the ethyl. That means this is the wrong numbering. If you would have wrote your longest parent chain numbering, you will see that the name of this will go prioritizing the tert-butyl or 1,1-dimethyl ethyl, because you want to give it a 4 versus a 6. Ignore the white numbering. The name will be 4 parentheses 1,1-dimethyl, okay, ethyl, that represented the tert-butyl thing. And then now we can now list the ethyl group, the other substituent. It will be 6-ethyl, longest chain 9 carbons, known. There's no double bond, falls under alkanes. So you see again, we prioritize D over E, and we consider the di D here because it is in parentheses. If it were not in parentheses, we will be considering the M, not the D. Okay, I hope that helped. Practice naming them. Practice makes perfect. See you in the next lesson.